184 letter case permutation. Given a string S, you can transform every letter individually to be lowercase or uppercase to create another string. Return a list of all possible strings we could create, and we can return it in any order. So let's go through an example. In this example, the string given to us is A1B2. So what we are going to do is we are going to generate all the possible permutation of uppercase or lowercase of the letters in this string. So what we need to know is if the element that we have at each index is an alphabet or is an integer. So first thing we are going to do is we are going to start from the first index, and which is index 0, and we check if we have an alphabet or not. And this is an alphabet, and if we have an alphabet, we are going to consider a lowercase and we are going to consider a uppercase for that. And then we go to the next element. The next element is an integer, so there's nothing needed to be done, so we are going to just add it to the a string that we are creating. So far we have two strings with lowercase a and uppercase b. And then we go to the next one, which is b. B is an alphabet, so we are going to have lowercase b and uppercase b. The thing is going to happen here, we are going to have a lowercase b and we are going to have an uppercase b. So it's going to be something like this. It's going to be a1 lowercase b and a1 uppercase b, a uppercase b and a uppercase and uppercase b. And then we check the next element, which is an integer, so there is nothing needed to be done, so we are going to add 2 to all the list, and we are going to return this as a result. For doing this, we are going to use a recursive function, and we start from index 0, and we use slices, and we check the elements that we have at the index, and if it is an alphabet, we are going to call the function twice, one for uppercase, one for lowercase, and if it is an integer, we are just going to add that like element to the string. So let's say the recursive, we are going to define a recursive function which is going to get s, and it's going to get a partial which is the string at each point, and it's going to get results, right? And I'm going to define these here. So what we're going to have, let me clear this here. We are going to have we are going to call this function. We are going to say return self dot recursive, and what we need to give, we need to get the string, we need to give the empty string, and we need to give it a result, right, which is going to be a list of all the possible permutations that we are going to return. And now what we need to do is we need to build this recursive function, and for doing that we are going to say if the we check the index 0 at each point of time, we check if that at index 0 we have is alpha. What we are going to do, we are going to call this function recursively. We are going to say self recursive, and what we are going to pass in, we are going to pass in from index 1 all the way to the end, because we just check index 0, and we are going to add the index 0 of the string that we had lower to the partial typo, and we are going to have results here, right? And we are going to do the exact same thing for uppercase. Let's see how it works. So we are going to have self recursive, and we call it for the string from index 1 to the end, and we are going to uppercase the index 0, and it's going to be plus partial and results, right? And the other case is if it is not alphabet, and if it is not alphabet, we are going to call the recursive function still from index 1 to the end, but what we are going to do, we don't need to do anything with index 0. We are going to just add it to the partial and results, right? That's it. And finally, we are going to return results at the end. What needs to be done here is we don't have base case here. We don't know when the like recursive function should stop. So for the base case, we are going, as you see, we are doing the slices, right? So we are going to make sure the length of s is not going to be smaller than 0. And if the length of s is equal to 0, we are going to add the partial that we have to the result. So append partial. So because if the length of a string is 0, which means we are at the end of the string and we have checked all the different conditions. And let's see why this is red here. So let's run the code and see how it works. Okay, there is a problem here. Results, so typo. So what it says here, it's we have the length of s is equal to results dot append, and we return the solution, and we are going to say if this is dot alpha, we are going to check that at index 0 dot lower plus partial, and then we are going to do the same for upper plus partial, and for this one we are going to just say 0. Actually we should I made a mistake here. The partial should be partial plus, not the string at index 0 plus partial plus. There we go. I fixed this, and the same thing should happen here. Partial plus at index 0. Oops. Okay, here we go. And I believe this should be fine. We're going to return. Let's run the code. It says the index is out of range, so that's a strange. So it's a difficult. We're going to say result.append. Oh, I forgot to return the results here. Return results. There we go. Should be fine now. There we go. And thank you.